Hello everyone, my name is Katrin Angerbauer and I'm a PhD student at the University of Stuttgart in Germany. On behalf of all my other co-authors, I'm really happy to be presenting at CHI for the very first time. For the next 8 minutes, we will be talking about accessibility for color vision deficiencies, challenges and findings of a large-scale study on paper figures. To begin with, let's refresh our memory on human color vision. In our paper, we consider a number of trichomonies and monochromatic vision, to which we refer to as color vision deficiencies, or CVDs for short. CVD accessibility is already a well-researched topic within HCI and visualization research. However, we wondered, how well is this research actually turned into practice? In particular, how accessible are figures that we ourselves use in our own research papers? Are there specific issues, or can we see trends over time? To that end, we contribute a large-scale data study. As dataset, we use the VIS30K dataset, which contains images from IEEE VIS publications. Here, we selected 1,500 images from 5 years in a time period between 2000 and 2019. Then we generated CVD simulations of those images. Finally, 200 crowdworkers on Amazon Mechanical Turk annotated those images with respect to labels we previously identified. Each image was rated multiple times by different crowdworkers. Let's have a look at our identified labels. We identified issues as well as helpful aspects which were related to color or rather generic. As an example of a color issue, it was problematic if highlighted elements did not pop out anymore because of the color change. While it was helpful if an image could convey meaning by just using one color. If an image appeared to be blurred or pixelated because of its resolution, it was a generic issue. Generic helpful aspects, on the other hand, often refer to double encoding information, such as using texture in addition to color. How was the crowdsourced labeling set up in detail? Crowdworkers saw the original image and the simulated image side by side and could provide annotation with regarding to the present issues and helpful aspects. And also they could rate the simulated images' accessibility and provide comments for us. Let's jump directly into the results. How accessible were the images? In our paper, we report the minority rating, so if at least one annotator rated as such, or the majority ratings if the majority of the annotators rated like this. So overall, 60% of the images were rated as accessible by the majority of coders. Monochromacy had the highest not accessible ratings. Did accessibility change over time? Based on our data, we could not find any clear trends in either direction, so future research needs to take another look on that. Regarding the most common issues for red-green deficiencies, the majority identified issues that were rather generic, such as low resolution, as most common, while if you look at the minority ratings, color issues become more present, in particular for tritonomy and monochromacy. We also ranked our images with respect to the ratings, issues, and helpful aspects and discovered that simple visualizations, such as schemas, seemed to rank as more accessible, while images that had problems with resolution ranked the lowest. We also applied dimensionality reduction algorithms to our data to find potential clusters, and here you can see scatter plots of images either colored by CVD or colored by accessibility, And I want to present to you the monochromacy island, i.e. cluster B, where almost all monochromatic simulated images were located, and C is a cluster within this cluster where images were rated as rather accessible, so we hypothesized that those images work well with just one color. For more results, I refer to our paper. You can find comment analysis in there, or correlations, and many, many more things that I don't have the time for, unfortunately, to discuss further. So let's talk about challenges and opportunities. Our data analysis proved to be a bit challenging because of the subjective nature of accessibility. You could hardly distinguish subjective opinion from noise, so quality checks were a bit time-consuming. But as we did an exploratory study, we also valued variety of opinion over highest agreement, which also brings me to the next point here, how to summarize the data. To honor the individuality of accessibility, we decided to offer different perspectives into the data, such as minority and majority ratings. And finally, leveraging the perspective of the crowd proved both to be a challenge as well as an opportunity. We discovered that subjective tasks such as ours required higher communication efforts because crowd workers were often unsure. On the other hand, when analyzing participants' comments, we discovered also intrinsic motivation for some crowd workers, which was definitely an opportunity. With that, I already conclude my talk. We contributed a large-scale study on CVD accessibility of paper figures. We discovered that accessibility labeling is not a standard labeling task. So if you want to do that, bear in mind that there might be higher communication efforts and challenging quality checks. But a point that is also close to my heart that I want to stress here also is that awareness of different vision abilities is important. And in the future, we want to dig deeper into our results and do more studies to gain an even deeper understanding of visualization accessibility. Thanks for listening, and in case of questions, do not hesitate to reach out to me. Stay safe.